If you take Earth, our entire world, with all its oceans and continents, and try to fill the volume of Jupiter, you would need over 1,300 Earths just to pack it full. Listen to this. That is real data from NASA's Chandra X-ray Observatory, translated directly into sound. You are hearing the high-energy radiation crackling across Jupiter's polar auroras. Jupiter functions as a violent churning energy engine, driven by intense internal heat, constantly erupting with storms larger than our entire planet. To understand how this giant works, we cannot just look at the clouds. We have to fly in and survive an assault from its outer defenses. This diagram shows Jupiter's true boundaries. The planet is surrounded by an invisible magnetic field stretching 20 million kilometers into space. If you could see this magnetosphere from Earth, it would appear 5 times larger than a full moon in our night sky. That field acts as a massive particle accelerator. It traps volcanic material continuously erupting from Jupiter's moon Io and whips it into a deadly, high-speed radiation belt tightly circling the planet's equator. Any human stepping into this orbital zone with heavy shielding would absorb a lethal dose of radiation in a matter of hours. Standard spacecraft computers would be instantly destroyed. Modern space probes sent here, like the ESA's JUICE spacecraft, are built like armored tanks. They carry their sensitive electronics entirely inside thick, lead-lined vaults just to survive the approach. Measuring the planet's deep water levels and chemical composition requires instruments to operate from within these radiation belts, close enough to see past the magnetic noise and into the deep atmosphere. This image from the Juno spacecraft takes us directly into the top cloud layer. We are looking down at a vast network of geometric cyclones, with deep shadows revealing towering cloud structures. The friction inside these deep storms generate flashes of shallow lightning that register up to 1,000,000 times stronger than a lightning strike on Earth. Updrafts carry water ice crystals into the freezing atmosphere where they collide with ammonia gas. Acting as an antifreeze, ammonia melts the ice into liquid droplets. They grow an icy crust, forming slushy hailstones called mushballs, and begin a massive freefall. Falling downward, the mushballs drag vast amounts of water and ammonia deep into the lower atmosphere, drying out the upper layers of the planet in the process. Jupiter's weather is powered by boiling internal heat and chemical antifreeze reactions occurring in total darkness. To map layers below the weather, astronomers study images like this. These dark brown bruises are 1994 Shoemaker-Levy 9 comet impact scars. They punched holes through the clouds, letting telescopes detect heavy elements like sulfur and carbon bubbling up from the interior. Sinking past those atmospheric layers, the pressure and temperature spike. Eventually, you hit a boundary where hydrogen and helium can no longer physically exist as gases. The crushing pressure forces them into a supercritical fluid. This is a state of matter that shares properties of both a gas and a liquid, behaving like a vast, sloshing ocean of liquid metal. The pressure here is so immense that atmospheric carbon gets squeezed until it crystallizes. Solid diamonds form and drop out of the atmosphere, raining down through the heavy liquid metal fluid. The deeper you fall into Jupiter, the more the fundamental rules of physics and the states of matter are rewritten by extreme gravity. At the planet's absolute center, gravity meets a solid boundary. Juno revealed a distinct, massive core, rather than an endless gas gradient. This dense rock and ice core weighs up to 25 times Earth's entire mass. This massive center confirms that Jupiter began as a rocky world, sweeping up the solar system's early gas long before the smaller planets could form. The core's composition reveals the solar system during its chaotic birth, showing how the largest objects assembled from the early disk of debris. Pulling completely out of the atmosphere and looking at Jupiter as a whole reveals the planet's broader role in the solar system. Jupiter operates as a cosmic vacuum cleaner. Its massive gravity pulls in or destroys billions of rogue comets and asteroids that would otherwise drift inward and strike the inner planets. That same gravitational influence likely flung water-rich bodies inward toward Earth, delivering the critical ingredient for life to our young, dry planet. Jupiter is an uninhabitable, radioactive hellscape, yet without its massive, destructive presence standing guard, human life on Earth would never have been possible.